Hi everyone, and welcome to another video on one of my favorite machines, the Mac Pro 4.1 and 5.1. In this video, I will explain how to install Windows 11 on this older but still nice machine. During the process, I will also upgrade the graphical card with an NVIDIA GTX 1650 and AMD Radeon RX580. Combine those GPUs together with Windows and we're in for some proper gaming as well. In the previous video I did on this machine, I already performed a dual CPU upgrade and installed a PCIe adapter and NVMe SSD in this machine as well. There are a few good reasons to run Windows on here. I already mentioned gaming and also the GPU. And while I will upgrade to a GPU that should work now in both Ventura and Windows, running Windows removes almost all of the limitations you have for a GPU. For example, if I would like to use this NVIDIA GTX 1650, since there are no drivers or kexts available for macOS, the experience will be really slow, even for simple tasks. On Windows, on the other hand, even though this is Apple hardware, it will be possible to use the full potential of this unsupported GPU. That doesn't apply only to GPUs. For example, I also have this USB 3 card here, which again, unfortunately, is not compatible with macOS, but works perfectly fine in Windows. Besides that, I just like to get Windows installed on unsupported hardware somehow. I don't know, I can't even explain why, but it's fun. Historically, Apple did support installing Windows in a relatively easy way by using Boot Camp Assistant. Unfortunately, this was only valid for Windows 7 and probably later also Windows 8. For Windows 11 or 10, this doesn't work anymore here using Boot Camp. In general though, installing Windows 10 or 11 on an x86 based Mac is not overly complicated, but this model specifically has some quirks which you need to be careful for, as it could even render your machine completely unusable. To explain all of this, I'll try to provide a bit of background of stuff I figured out in the past, so it will hopefully become a bit clear on why it's important to be careful. You can install Windows in two ways on this machine, in MBR mode or EFI mode. MBR mode is pretty easy, but has two drawbacks. First one, you will need to boot the Windows 11 installer from a DVD, as booting the installer from a USB will be forced in EFI mode. Annoying, but not too big of an issue. Second problem is that only SATA will be supported to boot Windows from an MBR mode. If you want to use an NVMe drive, like I have here, MBR is not an option. Using EFI removes these limitations, but it introduces a new issue. You could just hold the Option key on boot and install Windows by booting from a USB installer. As I mentioned, that will use EFI mode, and while this is easy, doing so results in secure boot certificates being installed in the Mac's boot ROM. The problem with this is that it eventually leads to NVRAM corruption and wears out the boot ROM. The result of this is a completely unusable machine, and the repair process is not easy at all. Even worse is that this doesn't only happen during installation. The certificates can also be written during the regular boot process under certain conditions. So in short, you really want to avoid that. In the past, on a similar machine, I did install Windows by directly booting from a USB installer, and I found out about what I've just told the hard way. After doing so, when dumping the boot ROM contents, we clearly see the X509 certificates in there. By clearing the NVRAM properly by holding down Command P and R for 4 times during boot, the certificates do get removed, as you can see in a new dump. Unfortunately, this doesn't restore the damage that was done to the boot ROM, and it doesn't prevent this from happening again, eventually leading to a completely unusable machine. So, in order to prevent this, we can again use OpenCore. Very similar as you can use it to boot macOS on unsupported hardware or an unsupported macOS version on a regular x86 PC, we can use this to boot Windows on this machine. OpenCore will protect the boot ROM from being written to by Windows and boots in EFI mode. So you get full support for NVMe storage, can boot the installer from USB, and as a bonus, you get to see the bootloader on an unsupported graphical card, which we actually have here. So we know what to do to get Windows 11 on here in a proper and safe way. Enough of the talking, time to get started. The starting point here is the same as at the end of my previous video, but I did reinstall macOS Mojave on an empty SATA SSD, as the goal is to install Windows on the NVMe drive. Since we need OpenCore to boot and install Windows in a safe way, I could now just install OpenCore from Mojave, and then boot the installer from there. That works to install Windows, but unfortunately, as far as I know, OpenCore is not able to boot Mojave. So that would require switching between drives to switch between Windows or macOS. And as my GPUs will not show any boot screen, this will be pretty annoying. So instead, I will first upgrade that Mojave installation to macOS Ventura. I will go quickly through all of this since I covered this in detail in a previous video already. I'll put a card here and a link in the description if you want to find out more. So, very quickly. First, I prepared a USB drive. Then downloaded OpenCore Legacy Patcher and used it to download the latest Ventura installer. Once that was downloaded and extracted, I created a bootable USB installer for Ventura. Followed by installing OpenCore on that one as well. Then, to actually do the upgrade, I just booted from the USB drive and clicked through the installer to upgrade the existing Mojave installation to Ventura. After quite some patience, the upgrade was complete. I then installed OpenCore to the EFI partition of the SATA SSD, and after a final reboot, I made sure that the root patches were applied to the system. For the graphics card, I still have the ATI or AMD Radeon HD7950 in here. Since a few versions, OCLP does support this card under Ventura and it performs pretty well actually. So before I go ahead and install Windows 11, let me first set a baseline of the performance. I ran the Geekbench 5 and 6 benchmark for both CPU and compute, which uses that HD7950 from macOS Ventura, and these were the results. We're good to go now. The plan is to install Windows 11 now on the NVMe drive. This should work in the same way if you prefer to use another SATA SSD instead of NVMe or even a separate volume on the same drive. I did format the NVMe SSD in advance with exFAT and gave it NVMe as label. This is not strictly necessary, but I wanted to be sure that I can properly identify this drive in the Windows installer later. As OpenCore is already installed on the SATA SSD as part of that upgrade to Ventura, and the Mac boots from it by default, all we need to do to install Windows without risking issues with the boot ROM is to insert a bootable Windows 11 installation USB and restart the system. As you can see, OpenCore shows the Windows entry now, which is the USB drive. I just need to select that one, press enter, and it will load the Windows installer. Looks like the installer starts as expected. We can also see by the slightly higher resolution we have that we are running in EFI mode. We can just run through this installation as on any other PC. Only thing we need to take care of, as you would need to do on another unsupported PC as well, is to bypass the hardware check. You can do this by pressing Shift F10, then enter regedit to open the registry editor. Create a new key called labconfig as follows. And then in the key, create two dword values, bypass tpm-config and bypass secure boot check. Set the values of both of these to 1 to enable them, and then close the registry editor and the command prompt. Now we can just go through the installer as usual. In the screen where you select where to install Windows 11, we need to make sure to select the correct drive. I can clearly see here that my NVMe drive is disk 1. So I will clean up all existing partitions and let Windows create new ones for me by selecting the drive. Now all we need to do is to wait and let the installation complete. During the installation, Windows reboots the machine several times. Each time we can see an open core that Windows is now set to the default, causing the installation to continue without interruption. If you would like to go to macOS, you can just use the arrow keys here to select it, but for now let's complete the installation first. Here we go. All that's left is to click through the small wizard. Or at least that's what I thought, as it looks like my screen went blank and the monitor seems to report an intermittent signal as soon as Windows started to install updates. After some troubleshooting, booting into safe mode seems to work. I figured the issue was probably related with the driver of that HD7950, seen as an R9200 by Windows. So I rolled back the driver to the basic display adapter and Windows seems to boot fine with that basic driver. Unfortunately, any attempt I did to install a better driver, like the latest drivers for the GPU from AMD's website, resulted in the same blank screen. After spending some more time on this, it looks like a known compatibility issue with this GPU and Windows 11, also on regular PCs, as it is considered to be no longer compatible and there are no working drivers available for Windows 11. I guess that gives us a proper excuse to go ahead and try another GPU, right? The first one that I will give a try is the GTX 1650 that I have here. After shutting down the machine, I will get the AMD Radeon HD7950 out and replace it with this card. Let's see if we manage now to boot into Windows. That looks better. Let me first install all updates, as I didn't have a chance yet for that, including all missing drivers. Again, this takes quite some time, but we managed to go through this, and this is how Device Manager looks like now. In other words, all clean. Everything seems to be fully functional under Windows. Even Bluetooth and Wi-Fi are working as expected. Just to make sure we get the maximum performance out of the GPU, I will also install the latest NVIDIA drivers. All done. Let's see how well this performs now. As I did in macOS, I will run the same tests here with Geekbench 5 and 6. Again, both for CPU and compute. And just look at Task Manager go. This looks truly impressive with 24 logical processors all doing their part and getting nice results for the benchmark. Speaking about results, here they are. In Geekbench 5, CPU performance is pretty much equal to what we saw under macOS, which is also as expected. In Geekbench 6, it looks like under Windows we have a slightly worse result, bit strange. For GPU performance, in Geekbench 5 we obviously get a higher result, as the GTX 1650 is clearly more powerful than that HD7950 which we used under macOS. For Geekbench 6 the difference is even higher. To be able to later compare the performance for gaming with this card, let me also run 3D Mark here. $3,964, not bad at all. Just to test, but we actually already know that this won't be a good idea, let me reboot the machine into macOS and see how that looks like with the GTX 1650. As I did mention before, this can simply be done by rebooting from Windows and then selecting macOS and Open Core. Doesn't get much simpler than that. Pretty sure we won't need to run Geekbench here, as we can clearly see that performance is really bad. After all, this card, and any NVIDIA card, no longer has drivers in macOS, since NVIDIA and Apple don't really get along anymore. Even when trying to run the root patches in OpenCore Legacy Patcher, we can see that nothing is available to fix this, so not much we can do here. And as expected, Geekbench doesn't even allow us to run a compute test. Alright, the GTX 1650 was kind of an intermediate test. The end goal is to upgrade with this RX580. The main reason for that, as mentioned, is that this one should be supported under both macOS and Windows. So a great choice if you plan to use both of these. Now, before we can install the RX580, I will need to take care of the power connector. The HD7950 used two 6-pin connectors. The GTX 1650, only a single one of those, but the RX580 requires an 8-pin connector. The Mac Pro has two mini PCIe connectors on the motherboard, which are each capable of delivering up to 75 Watt. The PCIe slot itself can do another 75 Watt. So that leads us to 225 Watt as the maximum that can be delivered to a GPU without any large modifications. By using a dual 6-pin mini PCIe to 8-pin adapter, like this one, we should be able to safely connect the RX580 as it is rated to draw a maximum of 185 Watt. After connecting that 8-pin adapter to the motherboard, we can just insert the GPU and connect it to the adapter. I'll also fix the bracket on the back. Let's boot the machine again and see what we get. Looks like Windows has no issues, but let's install the latest AMD drivers to make sure we get the maximum out of this hardware. And one more reboot later, it's time for benchmarking again. Once more, I reran the compute test in Geekbench 5 and 6. Under Geekbench 5, I get the result which I expected. A slightly higher score for the RX580 in comparison with the GTX 1650. In Geekbench 6, strangely enough, the RX580 scores lower. I did rerun the test multiple times, but got a consistent result. Not sure what is going on, I start to lose my confidence in Geekbench 6 a bit, as I'm pretty sure the RX580 is faster. So, to compare with the previous card, and to check if I'm right and Geekbench 6 is just a bit weird, I'll also run 3D Mark here. And the results are in line with my expectations and Geekbench 5. A reasonably higher performance score with the RX580. Nice. Now let's retest things on macOS as well. The RX580 should work fine with the necessary patches on Ventura here. So, after booting into macOS, I'll first reapply the root patches. Another reboot and all root patches are installed. So, once more, let's rerun the same tests from here as well. Unfortunately, the results, which you can see here, were not as I expected. The score we get in Geekbench 5 is really low. I did retest a few times, but always got around the same. And the Geekbench 6, which I'm not sure we can trust for 100% anymore, I managed to get a better score, but still way lower than what we get on Windows. I guess the patches make the card perform to an acceptable level, but it doesn't come close to the performance as we can get natively on Windows. Too bad. In the meanwhile, this video already got a lot longer than I anticipated, but what better way to end here with some games running on this Mac Pro 5.1. Despite this machine being now about 14 years old, it is still capable of running the newest games with a very decent performance. As long as you stay in Full HD, gaming is a real pleasure and frame rates are more than acceptable. I do have to admit that I did perform quite a bit of upgrades, but still, I think this is pretty impressive. Strangely enough, Windows clearly became the better choice now on this hardware if you want to get the best performance. Enjoy the rest of the gameplay. Thank you for watching. Let me know in the comments what your experience is with this machine. Leave a like if you have enjoyed this, and don't forget to subscribe if you want more of the same. Thanks again and hope to see you back here soon.